Hey everybody, welcome to today's Kubernetes Masterclass. Really happy to have you all on the line. We just have a huge number of registrants for today. It's a super popular topic, how to run a database in production on Kubernetes. We have about an hour and a half with you all and a ton of material to get through. But while people are joining the line, I want you all to know that this session is being recorded. So you will get the recording of the video as well as the slides emailed out to you all. We'll also post it on YouTube. This is intended to be educational and easily accessible, so we'll send it to you afterward. So let's go ahead and jump in. My name is Matthew Shear. As a way of introduction, my name is Matthew Shear. I'm marketing manager here at Rancher. Kind of host these sessions as well as our intro trainings on different days of the week. I'll talk about those a little bit more later. You can also see me as sort of like your point of contact person who, if you are looking for a resource, for whatever reason you don't get the recording or the slides, please reach out to me on email or on Rancher Slack. I'm just at Matthew. Happy to help you out. But the man who's really going to be doing the heavy lifting today is Matt Mattox, a support engineer. Matt, are you there?
Yep. Can you hear me?
I can hear you, sir. All right, awesome. Okay, well, I'll let Matt introduce himself a little bit more as we go. We have a double dose of Matthews today, everybody, so hopefully we don't get it confused. So a couple housekeeping items before we dive in. We have about an hour, 45 minutes, hour of content. We try to leave a ton of time for questions. We want to do our absolute best to respond to every question that is asked. We're going to kind of go through the demo and the slides and leave a lot of time for Q&A at the end. But there are, quite a few people on the line today. So my request is to just try to keep it on topic, to the material that Matt is presenting. And if we, for whatever reason can't answer your question or don't know the answer to your question, we'll probably refer you to another resource like our, Rancher Slack or forums or something like that. As I said, this session is being recorded. We will post it on YouTube. All of our other online trainings are there as well, our online meetups, our intro trainings and advanced trainings. So check out the Rancher YouTube channel. There's a lot of good material going back years. So don't miss out on that stuff. And I mentioned our Slack before. I have a feeling most of you are already on our Rancher user Slack, but if you're not, you're definitely missing out. There's hundreds of members asking and answering questions every day, thousands of members overall. So it's a fantastic place to learn and to get to know other people who are working on these technologies. There's also a masterclass channel just for this. If we need to make a special announcement or have files that we want to get to you all, we'll post it there too, so you can join that as well. And I just quickly put together our upcoming class list. So this week we have 2 more intro trainings. We're doing an intro to K3S tomorrow. So K3S, if you're not familiar, is lightweight Kubernetes distro that we've created, become very popular in the community. And then Thursday is an intro to Kubernetes and Rancher. So this training is going to be a little bit more, today's training is going to be a little bit more advanced, but if you're just new to Kubernetes or new to Rancher, then definitely join Thursday's training. All of these are totally free and live, and so we're here to answer your questions. And then next week and the following week we'll have 2 more master classes, one from our partner HPE and another on Kubernetes security. So don't miss out on those. Okay, so now that stuff is out of the way, we can get to the meat of the material, which is what you're really here for. So I am gonna pass this presentation over to you, Matt. Make you the presenter.
Okay, and you should be able to see my screen.
Yep, you're up. You're good to go.
Okay, so just to start off, we're not going to be in PowerPoint too much. I don't have very many slides. We're going to try to do a lot of stuff in demos today. A little bit of backstory on who I am. I'm actually on the Rancher support team. You open a ticket with Rancher support. I'm one of the guys that you're going to be answered to. And then I will release all of the scripts and examples and README files on GitHub, and that'll be part of the slides at the very end. So for our agenda, we're going to focus mostly on the requirements and design. Little caveat with this, I'm mostly focusing on MySQL and MariaDB just because of their maturity in Kubernetes, but a lot of these concepts and designs, they translate to all the other databases with, of course, caveats with everything. We're then going to go through and we're actually going to stand up two different flavors of databases, and then we're going to kind of go over some common scenarios and gotchas, and then we're going to close it off with just some recommendations to help you succeed with running databases inside Kubernetes. So to dive in, especially when looking at running a database in Kubernetes, these are the questions that I usually interrogate my application teams with. Not every database makes sense to run in Kubernetes. Not every database makes sense to run in PaaS. Same with VMs. So I usually break it down into these sections of, the first one is always availability. Ask your app teams, what is your availability? If I'm building a solution for a 7.9s database, it's totally different than a 2.9s database. And try to really be realistic with it. We all want as high availability as possible, but that has costs and caveats and penalties around it. The other one is, what kind of workload is this? Is this a WordPress site that just needs a simple database behind it? Or is this a transaction for an auction system that, those two different workloads, or let's say it's a science system where it's just getting terabytes of data in. Those are all different workloads, and that's really going to inform not only the technology, but what kind of solution we're going to build to meet that. The other big one, and it's kind of the naughty word in database, is data integrity. How important is this data to you? Is this data that if you lose a single transaction, it's the end of the world and everything comes grinding to a halt? Or is it okay to lose 5 minutes? Is it something where, yeah, if we lose 5 minutes, it's no big deal. People just have to relog in, or a report just has to run again. It's no big deal if we lose a little bit of data. Again, those are two totally different solutions. The other one is data consistency. Especially when you start looking at large scale applications. Does all your data have to be 100% consistent all the time? Does it make sense to do something like a traditional SQL database, or do you want to look at something like a NoSQL or Mongo or something like that can have a little bit of inconsistency, but you're trading it off for scalability and performance? The other big one is, not every database makes sense to put in Kubernetes. Not every database makes sense to put in PaaS. Not every database makes sense to put in VMs. This is off the official Kubernetes. Put it where it makes sense, is my rule. If it makes sense to put it in a VM because, hey, I need to throw so many cores at this and my application's got to be really close to it, it might make sense to put it in a VM. Or, hey, I'm building a totally DevOps microservice application. I want my database to be just another microservice as part of my application. Or, maybe in the middle. Maybe I don't want to patch VMs and deal with all the hassle of that, but I kind of want the stability of a PaaS offering. Again, these are the serious questions you need to ask yourself and ask your app teams. What makes sense? And also, don't be afraid to mix and match. I've seen lots of customers that have all three for a single application. Put it where it makes sense. Does it make sense to do Cosmos DB as a PaaS offering through Azure, and then do MySQL as a Kubernetes service, and then have a on-prem MS SQL that does some other part of your application? It's okay to mix and match. we're going to shift gears a little bit. We're actually going to dive into a demo. Again, all these links will be shared at the end of this call. The first one is kind of the classic starter that everybody always starts with. Straight up vanilla MySQL container, and we're gonna build it on top of Kubernetes 117. This works for most versions. In this case, I'm going to use DigitalOcean. Doesn't really matter what cloud platform. And then I have a pretty generic 3-node cluster. And then I'm of course using Longhorn as my high availability storage, but a lot of the rules apply no matter what storage you're actually going to use. So we're actually going to shift over here to the command line. And then, so this is my Rancher environment. I'm running, of course, latest and greatest. Again, this works without Rancher. So if you want to run this on EKS, all the same rules apply. So what we're going to start off with, let me cd into the right directory, is, let me bring this up here. So I built this as intentionally a starter application. So I'm not using Helm, I'm not doing anything crazy, just plain old vanilla. I'm gonna create a namespace, I'm gonna create my secrets with my awesome top secret password. So I'm actually gonna walk through that right now. Again, these are all will be provided later. Forgot to create my namespace. Cool. I'm gonna create my secret. For those that don't know Kubernetes that well, PVs and PVCs, think of them like hard drives. These are your hard drives of Kubernetes. And of course, we'll dive into a little bit more on these. I just want to get them stand up so that we don't have to wait. Next, so we've created the passwords, we've created the drives. Now we're actually going to stand up the database. And then now we're going to stand up I call it the VIP of the database. And at this point, we're going to check and see where it's at with starting. Cool. So, of course, I like to use the Rancher UI because it's a little bit easier to visualize it. And let me move this into the default project so you can see it. Come on. And of course, you're going to run slow. All right, wow, that's deciding it wants to load. So a little backstory on, these are just standard YAML files. In this case, I'm just using Longhorn. A lot of this, I try to make as generic as possible so it can be reused as much as possible. As you see here, it's very, very stripped down. I'm not doing anything crazy, just simple MySQL, passing in a root password, and then passing in a volume. And, okay, so it's up now. So we're gonna go to workloads, and it's already up right now. So this is the classic single node. As you see here, I have my workload, and then I have a pod inside there. If I actually want to jump into this pod, I could take a look at, come on, load, there you go. So this is the big thing. This, as far as Kubernetes is concerned, is just a regular old pod. The only thing that's kind of special about it is this PVC. This is a virtual disk that we're passing into to store our data. With the idea being that everything that's not in here is totally disposable and can be thrown away at any minute, and we'll just simply get recreated. And I should be able to see, okay, it doesn't have it in there. Now that we have our database up, one of the big trips that people have sometimes is, how do I get access to my database? I always recommend never exposing a database to the public internet. You're just asking for trouble. So in that idea, this database right now is only exposed internal to the cluster. So if you want to log in, even if you have the credentials in this top secret username and password, you can't get to it because it can't even resolve externally. Oh, I got an extra. But I can use kubectl to basically open a shell and open MySQL inside that container. So I'm actually running the MySQL client inside that container that we just spun up right here. The other option, kubectl also has a really clever trick with port forwarding. This is more of if you want to use something like MySQL Workbench or DB Beaver or any of the other GUI databases, you can basically port forward and create a virtual tunnel from your local machine into that Kubernetes cluster on demand. The nice thing is it's all done over SSL and it's all encrypted, so it's okay to do. So then we're going to shift gears a little bit now. So with this model, this is the simple model. This has the advantage of being super easy to spin up and not very complicated. It's just MySQL running inside of a container. The downside, I generally don't recommend this for any kind of high production environment. For one simple fact, this is not really high availability. So if I come in here, this is running on node 1. Let me grab the IP address here. And I'm going to be a bad admin. I'm going to SSH into that node. So this is the actual Kubernetes node that's running this service. And I'm going to be a bad person and power it off. Not shut down gracefully, just power it off, kill it. So right now your alerting and everything should be start freaking out. If I come in here and take a look at my Rancher cluster, I should see that node, this node will go offline in about 30 seconds once it times out and everything. The big thing here is because I was a bad person and just powered it off, this node's not going to be happy. Kubernetes is not going to be happy with me either because this node's going to go into unavailable, not offline. One of the key concepts is Kubernetes doesn't have a way to fence IO. So Kubernetes doesn't know, is this node really down right now? Is that database still up and I just can't connect to it? Or is it actually dead and offline? So Kubernetes always takes the safe approach of assume that I just can't connect to you. Let me get back in here. And notice it's not spinning up a new container. It's not moving it to another host because it doesn't know. It's going to require you to actually go out there and intervene with this container to tell it, hey, I know what I'm doing. This node is down. If this was patching and the node would come back after a few minutes, just let it do its thing. But I'm going to assume at this point that node's on fire in the data center somewhere and is going to be down for a period of time. So I'm going to take some manual intervention, and this is one of the tasks. A lot of the storage vendors, again, it takes the approach of data integrity is first. So I'm going to have to go out there and intentionally tell it, hey, get rid of this pod, unmount the storage, even though it's not really mounted right now. It still thinks it's mounted. So one of the things, even though I'm scaled down, because it's an unknown state, it'll just there. You actually have to force kill it. So I'm going to force kill it. I'm actually going to log into my Longhorn on the back end. And I could see it still thinks that that is attached out there and is currently in use. So I'm actually going to tell Longhorn, nope, you are no longer attached. That node is no longer existing. And at this point, I've now cleaned up and given Kubernetes now an option to bring up a new container in a healthy state. So it got set to node 3 in this case. This is one of the reasons that I usually don't recommend this for mission critical production workloads, or really most production workloads. What happens if this happens at 3 o'clock in the morning and you're sleeping? Yeah, maybe you script it out, but then do you script out, this is Kubernetes doing its job and protecting your data so it doesn't go split brain. So here, it's a backup. So we just had, for a node crashing and locking up, what about 3, 4, 5 minute outage? Is that acceptable in your environment? That's a question I can't answer for you, but that's a question you can ask your app teams. Is that acceptable? Especially in like a lower environment, like dev, that might be totally fine. Production, maybe not. So yeah. So that basically covers a lot of the single node. I'm actually going to power that node back on and let that clean up while I go to the next one. What I see more in the environment is the classic HA cluster. This is MirandaDB, which is a drop-in replacement of MySQL, running Galera for the clustering. This is a multi-master, all nodes except all transactions. All nodes are always in sync. You do pay a write penalty. The big thing that usually trips a lot of people up is there is no concept of clustered file systems in Kubernetes, especially with MySQL and Postgres and basically almost all the major database vendors. So each one of these instances of that engine is going to have its own pod, its own IP, its own volume. So we're actually going to stand that up now. So because this is a little bit more complicated, I'm going to use a tool called Helm. You notice that I don't have a lot of files in here either, because Helm does a lot of the heavy lifting for you. And this is great for things like CIDC, where I want my database to be just another part of my application. You should always have the goal of no humans should ever have to touch production. Nobody except for the admin should ever have access to production. I shouldn't have to install anything in production. I should have my CIDC do that all for me. So in this case, I'm going to use this Helm chart. This is just the official Helm chart. You can, of course, always pull this chart down and make your own. We're not going to go into that today, but just you always have that option. Of course, this is all open source. The big thing that is really, really neat is this is your, think of it like your configuration file for your cluster. So I'm telling it, this is the storage, and of course this is a lot of this is commented out because it just shows you the defaults. But here I'm going to tell it, here's where to get your image, here's where to get your cluster IP. Think of it like your VIPs that you're going to be used for your database. We can skip over a lot of this, but here's what I want you to do with passwords. If I don't give you a password, by default, it generates a random one and then stores it in a secret somewhere, which is generally that's a good idea because random passwords are always better than passwords that we pick. And then you see here, so this is creating the root, this is creating the replication. The big thing that a lot of people like is here is your MySQL configuration file. This is part of your code. You want to make changes in here and you want to add some extra setting. This is where Kubernetes really pulls ahead Versus a PaaS offering is I can go in and turn off binary logging if I don't want it on, or I can turn it on, or I can tweak a setting in my SQL and I could set it to whatever my little heart wants. You know, so I get the best of both worlds. I get all the customization I could do on VMs, but I get the flexibility of a PaaS offering. So it kind of sits in the middle there. The other big one that trips up a lot of new people is these probes. These are health checks. So Kubernetes is actively interrogating those pods, saying, are you actually alive? Are you really up? Are you really responding? If not, I'm going to take action to make you up and responding at that point. And then it's just going into the slave configuration. We can skip a lot of this. And of course, there's great documentation on their site that covers all the options, and a lot of these are actually just standard flags. So if you already have MySQL or MarindaDB or Postgres, a lot of these flags you can actually just copy your config into. But at this point, we're going to deploy this database, and this is the craziest part. I'm going to copy this line right here. Wait, hold on. Chopped off. So this takes a few seconds. I just deployed that database. I'm gonna go ahead and check the status. It'll take a minute or two to actually come up. But if I come in here, actually let me go in my namespace, put it in here so you can see it. It's just a little quirk of Rancher that if you create namespaces outside of Rancher, it doesn't know what project to put it in. So I just dump it in default. And let's see where we at. All right, so we're still there. Good. So if we come in here to the workloads, here is that workload that I just deployed. So the big thing that makes this different and kind of unique in the world of Kubernetes, Kubernetes is built around stateless applications. Databases are the farthest thing from stateless applications. You don't want to shut down a database unless you absolutely have to. You don't want it to change its host name or change its IP unless it really has to. So Kubernetes builds stateless. These will always get the same name. These will always get the same IP address, and then will always stay on the same node as long as that node's still there. There is a lot of caveats with stateful applications. A lot of this gets baked in at build time. One example, and it's kind of a real big pain, is storage. If I go in here and take a look at, these are just sidecars, this volume. So it created this volume. If I could actually go into my Longhorn, refresh that. So it actually created this volume. It's an 8 gig volume. This volume is going to be 8 gigs. There is no changing it. There is no resizing it as of today. There is other storage providers out there that do let you change that. And you basically have to hack your way around, basically like delete pods one at a time to kind of force the new size in there. It's totally not supported, not recommended. So that is one big caveat. Build your storage to what your projection is, not what it is today. Because the recommended approach today, mind you, I'm going to put that big asterisk up to that today, is migration. If let's say 6 months down the road, this is at 80% full, you need to actually deploy another copy of the database with a bigger disk associated with it. So you would just simply go into here, into my values, and where's my volume at? Let me just search. All right, so let's say I want to change this to 16 gigs. So I'm going to grab that same Helm command that I did earlier. And the only thing different I'm going to do is give it a new name. And this is one of the real big power of using charts in Helm. If I come in here and take a look, I just spun up another database. Now, mind you, it doesn't have the data. That Helm chart is just a configuration. It doesn't actually have the data. So you would be required to take like a MySQL dump and then load the data in here, or have some cooler mechanism to sync the data between the two. And basically the idea would be is you would migrate to this one, update your, again, think of these are like VIPs. So right now this points to the first one, this points to the second one. You would at some point flip over by either making a configuration change to your app to switch to 2, or take over this service point and flip over to the other application. It is kind of a pain, but it's the nature of the beast at this point. There is active work and development being done to make this a lot easier, because it is kind of bogus that you can't expand storage, because databases are the #1 storage consumers. The other cool thing is, it is especially when you're comparing against a PaaS offering, one of the downsides to PaaS is it's an external service. Even if it's an AWS, it's external. You're calling a URL. That might be in a different building than you. It doesn't have to be right next to you. This could be on the same node as you. You could intentionally set some rules, and I want my reporting service to stay on this node so that I don't even have to leave my CPU. I'm staying entirely inside my CPU. I'm not even going out in the network to get access to my database, if I'm running some crazy workload. The other big thing, and one of the reasons that I like to use Rancher UI, is metrics. Of course, we have Prometheus and Grafana built right in. This is like a few minutes to get data. But as you can see here, seeing my CPU, my memory, my network, and of course, if I had this up for longer periods of time, I could see this over time. I think the only thing that it doesn't show that I wish would show is storage utilization over time. And I believe that's in progress, but don't quote me on that. But the other big thing is these are, of course, an HA cluster. So unlike the standalone, if I come in here and I'm a bad person and I just say, delete that, Kubernetes will, of course, do its job and delete that. But if I come in and take a look at my and get endpoints, and let me scope it to the namespace. So endpoints, again, think of them like a VIP. And if I take a look, I'm not gonna type. That node is already on. You do have to build your application. This is, think of this like a TCP load balancer. It's not like jumping into the request and, oh, the backend member died, I need to replay this request. Your application does disconnect at this point if it just so happened to be connected to that instance that went away. So you do have to have your application designed in such a way that it can handle that disconnect and reconnect. But the nice thing is it's really fast. And a lot of times most applications, it times out and immediately just reconnects. And if we're fast enough, you can see this is the other big thing with stateful sets. As you see, this stayed 0. Even though I deleted that pod and it got recreated, it still kept the same name. So this name will always be 0 no matter what. The other big thing is it will always have, I think it's this one, yeah. It will always have this volume no matter what. A little side note on Longhorn. and I'll touch a little bit more on this later. I like to use Longhorn simply because it has the built-in backup. There's other tools out there to do backup. This is just stupidly simple and it's free. And of course that's gonna do its thing. And let me also be really mean to this guy. So this guy's still doing its job. We can actually take a look at, see what it's doing. So it's, it's hooting and hollering because I killed it. The mount point's still there, and Kubernetes is basically gonna wait and time out. I'm gonna be really mean to it, and I'm going to power this guy off again. This is node 3. And let's just to prove I'm not doing any kind of smoke and mirrors, let me connect to the actual database. And of course my internet's kind of slow. And there, I'm connected to it, even though one of the members is physically powered off right now. The service discovery automatically kicks in and takes that out within a few seconds. So it should be little to no disruption in your environment. And of course, they're all not happy because that node's down right now. And let me go ahead and power that guy off. That's pretty much it. From what I see in the environment, I see a lot of MarianaDB Glinda clusters. Sorry, Galera clusters. I don't see a lot of standalones. It's usually special use cases. Galera has been in Kubernetes basically from the beginning. So it is fairly mature. There's a lot of charts, there's a lot of documentation out there. I think the only thing that, and of course it disconnected. The only thing I would put a caveat is there is known issues with the current .4 version, 10.4, where it just basically has issues. But the big thing to remember here is this is just a Galera cluster. So if, let's say, you powered off all 3 nodes, you still have to go through a crash recovery process, do a leader election. Now the nice thing is because there is an overlay of Kubernetes, it can do some really smart things, and like it always brings node 0 online first. So a lot of times you don't run into a lot of the crash failures. So let's say you had a cluster outage because somebody tripped over a power cord. Generally speaking, Galera on Kubernetes is actually a lot more resilient, simply because it's always going to come up in a very predictable fashion. If not, you simply just follow the exact same process that you would do in a regular Galera cluster of going through and doing a node election, putting it through recovery, and then having the other nodes. And there's documentation that goes over that, so I won't go too deep into that. And shift gears a little bit. So just to wrap it up with recommendations. Again, these doesn't matter what the database provider is. These cover all of them. The number one thing, especially when you're starting, have a test cluster. Have a test database that you can do a drop tables, you can bang on, you can run scripts against, you can run a lot of your automation against, and you're not afraid to mess up. Oh shoot, I typoed, no big deal. The other big thing, especially when you're starting off, intentionally break your cluster. Be the bad person that powers off a node. Be the bad person that reboots all the nodes at the exact same time. I'd much rather break my test cluster at, in the middle of the afternoon where I can spend all day researching it and figuring out how to fix it versus 3 a.m. when it's a production outage and Sleepy Matthew is not the smartest Matthew in the world. The other big one that helps a lot, labels. Label, 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 label your stuff. Especially when you start using, little side note, I am working on a process using our Submariner product to do geo-replication with MariaDB, where I have multiple clusters spanning geolocations and then replicating between them. That's kind of where the industry is going, especially with databases. Everybody wants to be database redundant, data center redundant. So especially having good labels and having good naming conventions, that's going to help a lot. Name your primary instance primary, name your secondary instance secondary, so you don't accidentally drop primary when you meant to drop secondary. The other thing, and this really goes back to the original break it, be comfortable with your recovery processes. Intentionally do really stupid things like delete all your nodes and go through the process of recovering at that point. Do effectively DR testing. The other one is document. One of the downsides to Kubernetes is it is so easy to set up. A lot of times people forget. And again, 3 a.m. Matthew is not the smartest Matthew and doesn't remember a lot. So documentation is your friend. The other big thing that trips up a lot of new people is backups. Kubernetes is not an excuse to not back up. Kubernetes is not going to protect you from somebody doing a drop all tables in production. It's just a database. It's going to do what it needs to do. There is a lot of open source tools. I mean, one of the downsides to Kubernetes is there's not a lot of integration with things like Commvault and TSM and NetBackup and all the other big iron backup providers. That's coming, especially the storage guys. Of course, always follow the 3-2-1 rule: 3 copies, 2 different forms, 1 offsite. The other big thing is no backup is ever valid until you've tested it and documented your restore procedure. And again, this goes back to break your environment. I don't want to do my first restore at 3 o'clock in the morning in production. And again, that goes back to my earlier point is when you build your backup strategy, build it. It's okay to mix and match. If it's a batch process where I'm standing up a standalone instance that's only going to live for the life of that job and then go down in 30 minutes, do I really need to back it up? No, I'll just rerun the job. Versus, hey, no, this is my critical database that's running my website, so it needs to be backed up, and I want incrementals every 5 minutes, and I want transaction logs turned on, and I'm going to ship transaction logs off. All that kind of stuff you could do in Kubernetes. And there's also nothing stopping you. These are full databases. As far as, like, let's say you wanted to replicate to on-prem, it's just a MariaDB cluster. You can set up log shipping and replicate. There's nothing stopping you from replicating it from AWS to DigitalOcean or to on-prem up to the cloud. It's one of the big advantages over PaaS. Try to do that with AWS RDS. They're gonna laugh at you. And then I'm just gonna go to the resources. At this point, I'm going to shift over to questions. Again, I'll be publishing this all in this GitHub repository. It's got all my charts and examples. Again, there's passwords in there, like password, so please change that. Do not run password in production. But at this point, let's shift over to questions. Matt, do we have any questions?
Yeah, awesome, Matthew. Thank you so much. Okay, let's go into these questions. I'm just going to scroll through these, and now is a good time. So just so everybody knows that there's several people who have asked if the session is recorded. It absolutely is. We will put the recording on YouTube and email it to you. Also, we'll email you the PowerPoint that Matt is referring to. Okay, here's the first one I see. This is from Amit, who says, not sure if you'll be able to answer this, Matthew, but he says, do you have customers using NetApp or Portworx as the persistent storage layer running databases?
Absolutely. So I used to be a storage guy, so that's kind of my deep background. We see a lot of NetApp, we see a lot of Pure Storage, we see a lot of EMC. A lot of the big iron guys and all flash guys have really jumped on the bandwagon, and it's kind of I mean, I like Longhorn because of course it's a Rancher product, but Pure is really fast, NetApp's really fast. It is also a lot of the replication and backup stuff is already integrated. A lot of the other software defined, this might be a little bit of a controversial viewpoint. If I was like a Fortune 500 company running a mission critical application, I might stick with Big Iron for my backend storage just for the maturity level. Rancher Longhorn is not GA. I use it in production a lot. It's used a lot in production, but then again, there's no support for it right now. But that's up to you at that point. I hope that answers the question.
Yeah, it's great. Okay, here's the next one. It's from Arvin. It's sort of more an intro question, but I think it'd be helpful to just make it clear. He says, does Kubernetes provide a load balancer and a fail-safe mechanism?
Yes. So that goes back to, and let me actually just show it. One of my clusters is not happy. So that goes to that service. Think a service like and of course this is down. Think of it like a TCP load balancer. As long as the pod is reporting healthy, and by that it means that it can go into the engine, it can make a database call, and the database returned a valid response. At that point, that IP address is part of that VIP. If one of the engines is having an issue, node ran out of memory, node ran out of storage, whatever. If it stops reporting as healthy, it gets pulled out, and it gets pulled out fairly quickly. You still might lose transactions. If you need to maybe be able to replay transactions, there's nothing stopping you from running like SQL proxy or some of the other more database type load balancers that understand requests and can do routing and stuff like that. Again, if you can do it in a VM, you can most likely do it in Kubernetes. But yeah, usually service rules are usually good enough for everybody. So you just build in a little bit of retry in your app, and you're golden at that point.
Okay, cool. All right, here, this is from Ollie, who asks, he says, we're mostly using Postgres. Do you recommend a solution like Stolon? I'm not sure if that's the pronunciation, Stolon, or are there better tools for Postgres HA setups?
I'm gonna have to. I would post that question in. I'm not a Postgres guy, so I'd hate to give you an answer. I'd probably post that in the masterclass Slack, and I'll see if one of the other engineers can answer that better. The big thing is if there's a Helm chart out there, especially if it's from the vendor directly, that's what I normally use, just because the vendor knows what they're doing, but I just can't speak to that.
Yeah, no worries. Okay, here's the next one from Dominic. We're just going to do marathon style questions here. This is from Dominic. So this goes back to your demo. He says, are the Docker images in the Helm charts you used built to run as root?
So for MySQL, by default, it runs as root. There's nothing stopping it from running as a different user. The only caveat that you have is if you're not running as root. So a little bit of a backstory. Close that. Where's my SSH here? It should be up now. A lot of the storage providers they are providing block storage to Kubernetes. And because of that, actually, let's go into here. Okay, that's done. So it's providing block storage. And because of that, you might have to chmod or chown those directories so that user account has permissions. So there might just be extra steps in there. Same thing if you're using like an NFS share or one of the other, Azure file or something like that. You might just have the extra step of when you first stand it up that you have to give those disk permissions, because again, it's just a file system. You have to give permissions so that other user can run it. But yeah, totally. I know MariaDB and MySQL and MS SQL all support running as different users.
Okay, cool. All right, here's the next one. This is from Ayadel. I'm sorry if I'm butchering your name. He says, do you have any experience to share using Kubernetes for large SQL server databases?
For which database technology? Like, are you saying like MS SQL, or are you just saying SQL in general?
Yeah, it's a good clarifying question. So Ayadel, if you could add that, and we'll come back to it. Okay, here's the next one. This is from AZ, who says, how about using NFS as the storage provider? Would you recommend it for databases or in any other workload?
So it works. NFS, again, I used to be a storage guy. There is a lot of overhead with NFS, especially in the kernel layer. Because again, as far as NFS is concerned, it's just a mount point on the box with a bind amount going into the container. So as far as like the kernel and all that's concerned, there's not like any performance penalty, but you're still dealing with some of the performance limitations. The big caveat is NFS will allow you to do multi-attach as long as your engine supports it. MySQL is a perfect example. MySQL doesn't support a clustered file system. So what'll happen is that one of the engines will come up and the other one hopefully won't come up, or it'll come up and they'll start fighting and you'll have database corruption. I generally recommend block simply for speed. But again, NFS is totally supported, and I do see it in the wild fairly frequently.
Okay, cool. Okay, so Ayadel gave us more context for his question. He had asked, any experience to share using Kubernetes for large SQL Server databases, and his specific example is Microsoft SQL or MS SQL.
Yes. So I'm gonna expand his question actually, because it's a really good question. Microsoft has really been throwing the gas on Kubernetes and Docker, and they've been really catching up hardcore, especially in the last year. A year ago, I would have laughed at anybody running .NET or MS SQL in Kubernetes. Today, I see it about 10% of the time in the wild. The HA clustering is still in preview for MS SQL. The standalone, I mean, it's basically just Express. Windows, again, it's not officially GA, but again, Microsoft's really throwing a lot of horsepower behind it. So today you're currently limited to standalone instances, unless you want to go into preview mode, at which point you have availability groups just like you would in a traditional Windows cluster. That just becomes what's your risk tolerance, how much on the edge do you want to be at that point.
All right. Okay, cool. Thank you. Okay, quick tangent. A few people have asked what SSH terminal app you're using. Is it called Cube, or can you tell us?
Oh, so this is Moby Xterm. It's the free version. You get like 10 sessions, and then it's like 40 euros a year or something like that, whatever that equals in US Yankee bucks. Yeah, it's phenomenal. I've used it for years, and of course it's like one dude made it. But yeah, it's Moby Xterm.
Awesome. Cool. Thanks, Pat. Okay, here's the next one. This is from Hans. He asks, could you talk about how you would upgrade the database server version in a setup, this setup? And the example is next GA release of MySQL or MariaDB.
Yep. So standalone, you would just change the image and redeploy at that point. One of the gotchas that always would get me is because you can't have that block device attached to multiple pods, you have to tear down the old pod first. And again, this is the standalone mode. You have to tear down the old pod first, and then you can stand up the new pod. In cluster, what you would use, and I think it's in this README. It's not. So when we did our Helm install, and we'll actually just do it again real quick. It actually gives you, and I'm just gonna do it again. Oh wait, hold on. It actually gives you the upgrade. Now, one of the caveats is there's only certain things with stateful sets that you're allowed to change. You're allowed to change environment variables, secrets, yeah, and passwords, and I believe it in the image. So if I wanted to, so this is that Helm upgrade command I was talking about. Let's say I wanted to go to version 10.3, which I don't think is officially supported in Kubernetes right now, but let's just for giggles. I would simply just come in here to my config file. Where is it at? It's up here somewhere. Yeah. Where are you at here? Yeah. So I would just change my tag. I think it's actually defined somewhere else. But yeah. So I would change this to 10.3, and then I would run this Helm upgrade command. And what'll happen is it's going to take those pods offline one at a time. It'll take the pod offline, get rid of the pod, but keep the disk. It's then going to start up a new pod with a new version or new settings, reattach that disk. MySQL and MariaDB will do their cool database upgrade where it'll update the files. And then as soon as that pod becomes healthy, it's going to rinse and repeat through the rest of the cluster until it's done. If that answers your question.
Okay, sweet, thank you. Actually, there's a couple more MariaDB questions coming in. This one is from Sujit, who says, does Kubernetes mount a virtual storage volume for each MariaDB node that then maps the same underlying file system?
No, so those are totally independent file systems. You in theory could mix and match. You could have NetApp on one node and Pure Storage and Longhorn. I wouldn't recommend it because you just would go crazy. But yeah, they're totally separate. It's one of the downsides to running inside Kubernetes, especially if you're using like a software-defined storage solution like Longhorn. In this case, I really have 9 copies of my database stored inside my cluster right now. I have 3 independent volumes, and then each one of those volumes actually has 3 independent copies as part of them. So it's very redundant, especially when you start getting large clusters. There's nothing stopping you from throwing additional pods on there for performance usually. But yeah, they're totally separate copies, and to actually lose data in the event of a disaster, you would have to lose effectively all the copies of those data, because all you need is one, because they're all full copies, to be able to bootstrap and bring everything back online.
Okay, cool, thank you. All right, here's another question. This is kind of slightly tangential, I guess. It's on Rancher OS, but it's database related. This is from Giovanni, who asks, is it possible to install and set up external tools for monitoring databases on containers with Rancher OS? That's on Rancher OS.
So, I mean, there's really nothing special as far as external access with Rancher OS. The only caveat you're going to have with Rancher OS is you can't like install scripts on Rancher OS because it's a containered OS. Same thing with like K3 OS. So you would need like either you'd have to run that monitoring process as a pod, which is probably the better option. But if let's say you wanted to connect into your database and pull some stat information periodically, there's nothing stopping you from exposing that database port to your network and then just connecting to it as if it's a regular old server. Again, there's security issues, and you have to make sure passwords are good and strong at that point. But yeah, as far as monitoring, generally, I usually rely pretty heavily on Prometheus and Grafana to do a lot of my stats. And then anything I need to go a little higher up the stack at that point, I'll generally just use the port forward option, which is this guy right here, to expose that database as just a local port, and then I can have my regular old scripts and tools connect to it as if it was just a regular old database at that point.
Okay, sweet. Thanks, Matt. All right, let's see, there's a few more questions that just came in. This is from David, kind of more of an intro to Rancher question, but I think it's helpful to ask here. Would you define Rancher as a good fit for an on-prem Kubernetes setup?
Yes. So backstory on me, I'm actually a former Rancher customer before I joined Rancher. Rancher kind of just makes Kubernetes easy. Especially on-prem, Kubernetes is kind of a pain to set up if you want to do it by yourself. And Rancher kind of just makes it stupidly simple. All you have to do is install Docker, and we have scripts to do that, and then run one command and the node's part of a cluster. And then Rancher just takes care of it. And of course, Rancher, we're fully compliant with Kubernetes. So if you want to go the hard way and build Kubernetes yourself and then just bring Rancher in to give you a pretty GUI for it, that works too. And we support everything in the middle as well.
RockCon, awesome. And David, we do an intro to Rancher and Kubernetes training every Thursday. This is a great question to go a little deeper there as well. And you can see a Rancher in and out. Okay, here, let's keep going. This is from Sarbit. I might mispronounce your name. He says, I want to set up replication between a live database server and another live database server. How do I set up replication?
So it's actually something I was working on last night in preparation for this, but it kind of fell apart. So the traditional way of doing it is, especially like, let's say you're using Galera, you would go in here, you'd follow the exact same process as this was a physical box or say a VM. You would set your server ID, you would turn on binary log transactions, Matt even put that as its own separate volume for speed, and then you would then expose this as a port. So you would expose 3306 to the world or to your cluster at that point. And then let's say you wanted to have a DR cluster, whether that's in Kubernetes or not. You would stand up that cluster the same way. You do a Helm install, with a different server ID and all that other cool stuff. And then you would then do your change master commands and point your DR cluster to your production cluster as if it was a regular old MariaDB cluster, and then block shipping takes over. Rancher does have a product called Submariner that helps make that a little bit easier. It basically creates like a virtual tunnel between clusters, so you don't have to expose things to the internet, and basically all pods can see each other. It's still a very alpha product, hence why it broke at 2 o'clock this morning and I couldn't get it fixed. that is something I'm planning on in the next like 6 months to provide documentation for doing that, because I think that's the only kind of big hurdle with running databases in Kubernetes is a lot of the DR replication just isn't there, and it's not easy yet.
Interesting. All right, thanks, Matt. Okay, here's more questions. This is from Weston, who says, this is in relation to scaling databases. He says, is there time to talk about, or could you talk about architecting tiered systems with read-write as upstream and RO downstream near the application layer?
I actually used to work for a hotel company that was where they had a 3-node MariaDB cluster for all their basically writes, and then they stood up a bunch of these read-only slaves. As far as how to do it in Kubernetes, what you would do is you do the regular Helm to get the initial cluster started. And then what you would do is you would create workloads for every one of those slaves, slave 1, 2, 3, 4, blah, 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 blah. They would usually just be a standalone. And then you would put them, again, just like you would do on-prem and on VMs, where you would set their server ID number. And then as soon as they come up, do a database backup and restore, and then point it to the master and point it to the binary logs and let it rip at that point. It's not super elegant today. There is some manual process that would need to be involved. I do know our official chart that we have, which let me pull it up in the Rancher. Let me think. Let's go to this cluster. We do have a chart in official Rancher. Let's go to defaults. This is another good starting point. So this is a traditional MySQL master-slave configuration. So you could, in theory, do that and just scale up the number of slaves, and it handles the full process. So if I go in here to launch, and of course my internet is slow.
You need to get
You would just go in here to launch. Yeah. Type in, I think it's just MySQL, and then you can specify, okay, do I want just a single master, or do I want master slave, and tell it how many slaves you want. I'm actually going to go through the full process. Again, these are just Helm charts on the back end, providing a nice, pretty UI and making it really easy. So I'm going to go in here to this guy. This is the official one. I have extra charts turned on here. So that, oh wait, am I in the wrong one? Yes, I am. So yeah, this is just a single. Is that MariaDB? I might be wrong on that one. But yeah, there's a chart in here. I don't want to waste everybody's time. There's a chart in here that will set that up for you. And again, the same rules apply as if it was a VM. Don't add 1,000 slaves to your master and expect it to just perform all happy and dandy. Again, as far as the database is concerned, it's just sitting on a really thin OS.
Okay, here's the next one, Matt. This is from Daniel, who says, and thanks for your patience, Daniel. I asked this question a while ago. He says, do you have any suggestions or examples on how to set up backup cron jobs for database storage on S3, third-party OSS, etc.?
Yes, I actually have a tool, MySQL backups. And again, this will be provided. This is stupidly simple. This just basically does a MySQL dump. of all the databases. The big thing here is I'm leveraging Kubernetes cron jobs. So Kubernetes has an internal cron job that can spin up pods on a schedule. It follows the same standard cron job format for, okay, I want it to run every, like this one every hour at the top of the hour. And then right now it dumps it to a volume. There is nothing stopping you from going in here and adding the S3, the AWS CLI, and setting up as part of the script that runs. So you could go in here and as part of that run script, just have at the end to do an sync to S3. Again, these are just bash scripts that are running. I do see a lot of that. And I also see, especially storage vendors have really embraced S3. So you might not even have to ship it to the cloud. You could be shipping it to on-prem. The other option, of course, is you could always just dump it on the host itself and then have like a rsync script swing by it and ship it off to something else too. That's always an option.
Cool. Okay, thank you. All right, here's the next one from Arvind. What scripting does Rancher provide for scaling and health checks?
So, let me. Oh, by the way, so this is the chart. It is the RandyDB chart where you can specify the number of slaves that you want. It just answers all the questions. As far as scripting, so let me break that into two things. And we'll actually just walk through kind of a dummy application here. So if you come here, Kubernetes has the concept of readiness versus liveliness. This tells Kubernetes when the pod is ready to start taking traffic. This interrogates the pod ongoing. These can be the same, they can be totally different. The big one that a lot of people use is HTTP request. So if, let's say you're running like a little tiny web server in there that's checking the database and returning a 200 response code, as long as it's getting a 200, then it's healthy. The other cool one, especially with databases, is command. So you could write a script, and as long as that script returns with a exit code of 0, meaning it returns successfully, Kubernetes goes, okay, well, this pod must be healthy at that point. And of course, you can always tune this too. How often do I want to check it? How many times do I want it to fail? And you can, of course, mix and match this. And this is just a Kubernetes concept. So I definitely recommend using readiness and liveliness checks because let's say your engine's kind of locked up, but it might not crash, but might just be frozen. So in that case, if you didn't have the health check, Kubernetes might leave that pod running because the process is still running, even though it's locked up. But this would actually go out there and say, well, you're not responding, you're failing this command that I'm sending you. You must be bad. I'm going to get rid of you and restart you. So I hope that answers that question.
Cool. Okay, thank you. All right. There's a few more questions in the queue. I think we'll answer those, and then we probably should cut it off.
Okay.
So let's get to these last remaining. And everyone, if you for whatever reason I missed your question did not get answered, please jump on Slack, hit us up there. There's a lot of expertise on our Rancher user Slack. Okay, so here this is from Vedant who says, we're using HDFS on Kubernetes for writing Parquet files, probably butchering the pronunciation, but Parquet files, and looking to move away from it. Any good alternative to HDFS?
To be 100% honest with you, I don't have the expertise to be able to really answer that question. I would probably post that in the Slack or on the Rancher forums. I just don't want to give you bad data.
Yeah, no problem. Thanks. Thank you, Matt. Okay, here's the next one. This is from Weston. So he says, in line with running the database as non-root and the ownership permissions a block level storage. Would you just have an init sidecar for the stateful set to address that?
Yes, yes. So mind you, there's a bunch of different charts. Some charts basically have a sidecar that does the init. It's personal preference. I've done it for some of my applications. So yeah, you could potentially do that. The only thing is that usually that init sidecar usually has to run as root to be able to do the permissions. But yeah, that would totally work. I think if you actually look at the official one that we have in our catalog, that has an init sidecar that does all the setup and configuration to bootstrap everything.
Cool. Okay, thank you. All right, here's a couple more. This is from Francois. This is following up on the scenario of two live databases, live database server replicating another live database server that you answered earlier was Submariner. He says, in this kind of cluster, can this kind of cluster be hosted on several regions, in several different regions like the US and the EU? And how would you deal with latency issues?
So yeah, so that's my long-term goal. I've always wanted to have a database that could fail between Amazon and like DigitalOcean and Azure. That's the nice thing about Rancher and Kubernetes is it gives you that common platform that we really don't care where it's sitting at. As far as latency, that's not really an issue usually. If it was on-prem to the cloud, it's a little bit of a different story. Internal Amazon latency is usually pretty low anyway. I mean, they have some pretty big pipes. And as far as the overhead that like Submariner, it's just IPsec. So, you know, as long as you have modern processors, which of course Amazon does, it's pretty fast. So you mean you do have the limitation of the speed of light. It only goes so fast. One of the things that MariaDB and we're running Glinda cluster is you can't do you can't do synchronous writes across clusters. You can only do asynchronous writes, or the other way around, because it basically does binary log transaction. So like perfect example, I had a customer that was doing that. They rolled their own, and they had to program into the part of their application is, well, I know there's going to be a 45 millisecond lag time between when this token was generated in this one data center, and if let's say my user gets sent over to the other data center, well, I might have to, if I don't see that token, I might have to wait 40 milliseconds and then check again, because you know it's not doesn't do remote acknowledgement. So it might be slightly behind. So you might have to build it in as part of your application. But that's just the nature of, you know, long distance. You wouldn't want to wait every write transaction anyway. There's nothing stopping you from running a Kubernetes cluster across regions. We've seen customers do it. The golden rule is 100 milliseconds. As long as you're under that, in theory, you're okay. Anything really above 100, Kubernetes is basically just going to fall over because it's going to start timing out. We don't recommend it. We would like to keep everything as close as possible for speed and performance, but there's nothing stopping you.
Yeah. Okay. Thank you. Cool. All right. Here's the last question, Matt. If I want to set up Kubernetes, this is from Sarbit, who asked, if I want to set up Kubernetes using Rancher, and actually this might be more of an intro to Rancher question for Thursday, but here we go. He says, if I want to set up Kubernetes using Rancher, what configuration server and disk is needed for setting up clusters of dev server, staging server, and live server?
Yeah, so that's really a intro to Rancher. Long story short, I'm not actually going to go through the full process of setting up a cluster. So I'm going to assume that you've already stood up Rancher, and we have documentation that walks you through that process. building your first cluster, which then hosts Rancher. The nice thing about Rancher is pick your provider. Do you want to bring your own nodes, or do you want to just plug into one of these providers and Rancher will handle managing and spinning up the VMs? So in this case, let's just select Amazon because that's what I feel like. These are node templates. This is a semi-new feature in Rancher. So I'm going to say I want my dev cluster, and I want dev, and I'm going to build my etcd. Think of this as the database for the cluster. This is the control, and then this is where your actual worker. Again, go to our intro class to really go deeper. But that's really all I have to do. I click create, and Rancher will start building those nodes for me. As you see here, yeah, so it's gonna call it to AWS to start provisioning. You can of course always bring your own nodes, and it's basically it gives you a Docker run and say go run this, and then it registers it, and then Rancher takes care of everything after that. Again, it's Archie on the back end, which is our own Kubernetes tool, which stands it up. You can, of course, you don't have to have Rancher. You can use Archie as a standalone product as well. So if you don't like Rancher for some reason, you don't like our blue color and just want to steal our tool, go right ahead. That's perfectly fine with us.
Awesome. Okay, thank you, Matt. That's such a fantastic job. Thank you so much. I think I'm going to end it there as far as questions go. I just want you to know that there was just a ton of positive feedback in the chat too. A lot of people were just thanking us. Yeah, thanking you for all the work you put in to the presentation today. It really shows. Thanks for answering all the questions. It was awesome. And I know there are a couple more questions that we might not have gotten to in just the bevy of onslaught of questions that came. So if we missed it, post it on Slack. Go to that pound masterclass. Go to that masterclass channel, and we'll try to follow up with you. And also, I'll throw this out there too, that if you guys have any other topics that you'd like us to do a class on, put that in there. Maybe we'll do some polls or something. But join that masterclass channel, and we can see what your suggestions are, and then create some more topics for the coming weeks and months. So as I said, the session is recorded, and we will send out the recording and the PowerPoint. I think Matt has some YAML files and some files on GitHub that we'll send out as well. So you will not miss out. All right, thanks everybody. Matt, awesome job. Thank you so much again.
All right, thank you everybody.